Let's do some examples then of trying to find confidence intervals for means. Okay, so if you read through the statement here, we're saying we're taking a sample size of 40. From the sample, we found the average. This is the sample average. Okay, and then here it's saying assume that the standard deviation was known. Okay, so here it's saying assume that the population standard deviation was known. This is sigma is 8 hours. Okay, so I don't know how they knew this. This is kind of textbook world where you can just pretend you know things that you wouldn't know. It would be very difficult to know this, but apparently we are being told that is what sigma is. In this case, sigma is known, so we will use the Z version of the confidence interval. The formula looks like this. Okay, so we want to be 95% sure in our interval. So here we want 0.95 and 0.025 is going to be in this tail. 0.025 is in this tail. If we went to the Z table, you've seen it now a few times. 0.025 goes to this value, negative 1.96, 0.06. Okay, so then you can just put X bar in. We've got that. Plus or minus 1.96 times by sigma, apparently we know it, is 8, and divided by root 40, which is the sample size. Okay, so here this is the standard error, or the standard deviation of the sampling distribution, and it times by the standardized jumps, the number of standardized jumps. This multiplied by this is called the margin of error. So we are we think that our best guess is 9.85 plus or minus some margin of error. Finally, we find these two interval values, and we can say that we're 95% sure. The average time spent in meetings for all profs, not just the 40 we sampled, is somewhere in between 7.3 and 12.33. Let's see how to do this in Minitab. Okay, so we go to Stat, Basic Statistics. This is a one sample Z. Especially if you hover, you can see it's giving you a description. We're trying to determine whether the mean differs when the population standard deviation is known. Okay, do we have sample data in a column? Not this time. We could if we wanted to. What would that look like? So here, if you had your data, if you had your 40 points, I don't know, Professor 1 spends 5 hours a week and Professor 2 spends 11 hours, okay? So this is called raw data. You'd have 40 of these points. That's what it would look like if you had data in a column. We don't have that. We've got summarized data. Where it says the sample size, this is 40. The sample mean, this was 9.85. And the known standard deviation, this is sigma, is 8. Go to options. We want to be 95% confident, and of course if we want an interval with two bounds, we want the not equal to sign. Here we're 95% confident that the range is in between this and that. Okay, so that's fine. That's where I got these values from. You could also do it by hand here. Okay, just a quick question then. If I increased my confidence from 95 to 99, what would happen to the interval? As we saw before, remember if we had 100% confidence in what you think you're going to get in an exam, I can be 100% sure it's in between 0 and 100. Okay, so well, the point is when you increase confidence, your interval gets wider. Okay, your interval gets a little bit less powerful in what it's predicting. Okay, if I lower my confidence, I get a tighter interval. It's saying something more specific, but I'm not as sure that it is true. Okay, so let's see another example here. You can read through it. The sample size is 200. X bar is given. And here, apparently, this is much more realistic. We don't know what the truth is of everyone. All we can say is that the sample standard deviation from these 200 apparently was this. So this is S. Here, sigma is unknown. So sample standard deviation is known, population standard deviation is unknown. Therefore, we must use the t distribution. Find the sampling error. This is just S divided by root n. This is also called the standard deviation of the sampling distribution. Okay, so this is 4,500 divided by root 200. Here's the standard deviation of the sampling distribution. If I wanted to be 95% sure of an interval that I make, then I'm going to use this formula. Okay, so here I know what X bar is. It's given to me in the question right here. I know what S is. It's given to me right there. I know what N is. It's given to me right there. What I don't know is T. Okay, so here if I want to be 95% sure, of course that means I've got 2.5% hanging out in each side of the tail. But for a t, you need to also know what is the degree of freedom. Here sample size is 200, degree of freedom is n minus 1, so 200 minus 1, this is 199. This is what we're going to do. We're going to try and find this t value. Okay, if you're using a table, let's go to the table. The first step is to find your degree of freedom. Okay, so here our degree of freedom was 199. It's 200 minus 1. Unfortunately, this t-table only gives you in between 100 and 1000. Up here it does a better job, but down here, again, there's restrictions on the table. So here, I guess the closest one would be 100. That's about the best we could do. Okay, so here we go up 0.025, where it meets up with 100. That looks like right here. The t-value we would use is 1.984. Okay, so that's what I'm trying to say. We'd have to use the closest one. If you have Minitab, you don't have to do that. You can find the exact value. I would go to Calc, Probability Distribution, and this is called the t-distribution. Okay, so here in this case, I've got an area and I want a value. So I'd use the inverse cumulative probability option. The degree of freedom was 200 minus 1, or 199, and one of the tails was 0.025. Okay, we estimated the value being 1.984. The exact value should actually be 1.971. Okay, so here you can see that the table would give you a little bit of rounding error, whereas Minitab you can find the exact value. Okay, it's giving me the negative, of course. Why is it giving me the negative? I gave it 0.025, so that's why I'm seeing the negative. If you wanted to see the positive, you could say 0.025 plus 0.95 or 0.975, and you would get just the positive counterpart. It would just be positive 1.971. Okay, then if I was doing this by hand, I could use either this value or I could use the value from Minitab. Minitab can actually just calculate it for you without doing it the long way. You can go to Stat Basic Statistics, one sample t. Okay, so here, do I have my samples in a column? No, I've got summarized data. Okay, what's my sample size? Here it was 200. The sample mean, let me just quickly refresh actually I've got the notes right here. It was 26,680. And here notice that it's asking for the standard deviation. Remember when we went to one sample Z, it said the known standard deviation. This is just the sample standard deviation. So here it says the sample standard deviation was 4,500. Let's click on options. What's the confidence level that you want to have? I want to be 95% sure. And of course, if I want two values, I need the not equal to sign. And here's how you can have Minitab calculate for you the whole interval itself without having to do it by hand in any way. Okay, so about 3 options there to calculate this interval. Here's what I did. Here's what I got when I was using the table values. Okay, here's what I got when I was using the software. You can see there's a little bit of rounding error. I really couldn't find the exact degree of freedom that I was really looking for. I did the best I could. You can see that there's not a huge amount of difference, but there is a little bit. Okay, so interpret the meaning. We're 95% sure the average debt of all recent graduates is between these two values. Okay, so here's an example where you can see some raw data. Okay, so here, when you're reading through the question, it says over a 2-month period, 16 samples. Okay, so n is 16. Here are the 16 data points. If you wanted, when you were in Minitab, you could type all of these data points into a column. I haven't done that. I don't really need to because it also gives me some summarized data. So you could do this. You could type this all in, or if it's as a file, you could copy and paste it in. And you could do it that way just fine. I also have some summarized data posted here, so that's kind of nice. The question is, do I use a Z or a T? Okay, when you're reading along, notice that we don't have any information about the population standard deviation. All we can do is just find out what the sample standard deviation is. Okay, so here we've got that given to us. Let me just do a quick sort of fake. So let's say, I mean, I'm just making up stuff, but let's just say I've got some missing ones that I've been able to put in my data, and I don't want to waste your guys' time by doing this slowly while you watch me. You could theoretically, if you put in the correct data, say that I have data in column 1, and then that's the only thing you need to tell it. Minitab can calculate the standard error, or the standard error, and everything else. You just tell it how confident you want to be, and then it says, here's the mean. Here is S, the sample standard deviation. Here's S divided by root n if you want it. This is the standard error. And here's the confidence interval. Okay, so that's, if you have raw data, you can do that just fine. In this case, however, we've got summarized data. Okay, so here's where I'll use the real numbers. Here the sample size was 16. The sample mean, it says, was, let me just flip the page here. It says that it was 5.05, and the S was 0.453. Okay, so then I can go to options, 95% confidence. Here it tells me, here's X bar. I told it X bar, but it's telling it to me back. Here's S. I told it S, but it's telling it to me back. Here's S divided by root n. And here is my 95% confidence interval. Okay, so again, you can do it by hand. If I wanted to find the t value from my t table, then here, oops, it looks like I've got a little bit of a typo. Okay, so this should be a 15 because the degree of freedom is 16 minus 1, so this should be a 15, not a 16. Let me just make sure I know what that's going to be. I'm going to go to the row 16, and here if I want to be 95% sure, it's 2.12. So happily this isn't a typo, however this is. This should be the 15th row, not the 16th row. Then of course I can sub this value into my formula and find anything I want. Here's the confidence interval. T times S divided by root n, this is the margin of error. S divided by root n, this is the sampling error or the standard deviation of the sampling distribution. Okay, so here, would you conclude that mu is less than 5? My interval is from 4.8 to 5.29. 5 is inside of it. I cannot conclude that that mu is less than 5. Much of this interval is less than 5, but not all of it. It is possible that, in fact, my guess is saying I'm 95% sure it's in between, anywhere in between here and here. So it's very possible that it's here. So we should not conclude that mu is strictly less than 5. In fact, it may be 5 based on our calculations. Finally, do another example here. Do I use a Z or do I use a T? Okay, here the sample size is 115. I go along and read what's going on. They give me some sample, some summarized data. Notice here I only have S. Nobody has said anything about the population standard deviation anywhere. Sigma is not known. Therefore, I really need to use a T, not a Z. Okay, so here then I can use the T. If I'm going to be 95% sure, you could go through with Minitab. Here, when I used Minitab, this is what I got. When I use the table, this is what I got. So here you can try that. Then we're comparing our interval, which is from 619 to 684. Does it contain the value 460? The answer is no. 460 is way over here. So it doesn't appear that mu is equal to 460. In fact, it looks like mu is significantly greater than that. As you can see, the whole interval is above 460. So it looks like here, if this is the average that Quebec spends, and I believe the average that Alberta will be is in between here and here, then you can say it looks like Albertans spend a significant amount more because 460 is not inside this interval. This whole interval is larger.